Hi, my name is Mark Hardwick. I'm here to teach you a little bit about how the brain develops from a fertilized egg. First, cell division occurs and you get what's called a morula. And eventually the body can no longer feed the internal cells, so it forms a gap, which the primitive yolk sac, I think it's called, which feeds the internal lining of cells. And then you get something called the epiblast, and that's what we're going to focus on. The epiblast, it's a sheet of long cells, so kind of imagine like an air mattress or something, or I can't think of anything at the moment, but anyway, it's this little disc of cells called the epiblast, and it gets kind of a little notch here, and that's called the primitive node. And the primitive node begins to send signals, and there's also a little gap that forms here, and this gap separates and begins to fold under itself, and in the end it forms three layers, and this is called the trilaminar disc. And you've got the ectoderm, mesoderm, endoderm. Endoderm forms all the smooth lining, kind of the internal tubes of the body. The mesoderm forms the structure that holds the tubes, and the ectoderm forms the tube of the central nervous system, and parts of the peripheral nervous system. Anyway, so that's kind of where we are. And anyway, once it forms this trilaminate layer, the inner part starts to dip a little bit. And remember, this is like a sheet, like a trilobite. You're going to see like a little spine form, and the formation of that spine is kind of this indentation where it wraps over and forms at the middle, and that is called primary neurulation, when this tube closes. And you'll get some there's some cells on the inner wall that begin to differentiate between the anterior and the dorsal and the ventral. And then at secondary neurulation is when the roof of it, like you've got your trilobite here with the spine going down the middle, this roof closes and this thing kind of extends out closed and forms a spinal cord. So you've got kind of this weird big tube here and this little bitty tube coming off the back. The big tube out there is the ventricles that will form in the brain later. You've got the prosencephalon, the mesencephalon, and the rhombocephalon. The prosencephalon diverges into the telencephalon and the diencephalon. The telencephalon bulges out. That will be the cortex, the lateral ventricles, and then you go into the mesencephalon, which is the midbrain. I think I'm getting something wrong here. I'm missing a ventricle. You've got the rhombencephalon with the metencephalon and the myelencephalon. The myelencephalon forms kind of the medulla oblongata a little bit. No, because the mesencephalon is the midbrain. The metencephalon is part of the midbrain and like the pons. And the diencephalon up top is the thalamus and hypothalamus and central brain structures, probably the nucleus accumbens and striatum. I can't remember what the striatum is. I think that's more in the basal nuclei, but neither here nor there. I know there was something more. You've got the central aqueduct region, which communicates third ventricle to fourth ventricle, because the first two ventricles are the left and right lateral ventricles. I'm blanking on where those are, but I'll have those up to speed by the time I need to. Thank you so much. My name is Mark Hardwick. I hope you learned a little something today. Take care.